All right, let's go through this sample test. Number one, looking for a writing pencil here. There we go. Number one. So the price of 100 shares of my stock went from $24.75 a share to $25.25 a share. Use the information above to write one true statement about the absolute change. So absolute change is how much it changed in dollar amount. So we would take the 25.25 and subtract the 24.75, and it doesn't say this, but it should say this is price per share. I'm missing a dollar sign. Boy, okay. Anyway, 24 to 25.75, that's 50 cents. So that's a difference of 50 cents, half a dollar. So the statement would be the price per share went up 50 cents. Use the information to write one true statement about using the percentage as a fraction. So I would go start with my starting amount and say 50 cents over 24.75. Oh no, we're going to do the 25.25 and 25.25, and we can do that is the which is, let's get that in percentage, 25.25 divided by 24.75. I'm doing it in the wrong place. Clear. 25.25 divided by 24.75. It's 102%. The new price is 102% of the old price. And true statement using percentage as a change. So this is where we do. So we do the absolute difference, the final value minus the reference value, divided by the reference value, 24.75, and that should come out to be 0.2. 0.5 divided by 24.75, and so that's times 100 is 2%. There was a 2% increase in the price per share. Okay. Last week, the price of gasoline in Cleome Warrior Stop was $3.19. It wasn't that. And at Safeway, it was $3.35. Write a comparison statement comparing the prices between the two stations using percentages. There's several ways you can do this. You can say put $3.35 over $3.19 and say Safeway's price is that percentage of Warrior Stop, or you can put $3.19 over the 335 and say Warrior stock price is that percent of Safeway's price, or you could say that would be the two that you can compare. So there's two ways you can do that. So I'll do this one, 319 divided by, so the reference becomes the denominator, 3.35. So Warrior Stops is 95% of is 95% of Safeway's price. Okay. Determine the percentage score that would belong in the bank. Allison scored 22% better on her second test than her first. She increased her score to, so if she went 22% better, she increased her score to 122% of her first score. 100% of her first score plus 22% more because it was increased by 20. Desiree took a 2% pay cut. She now makes, so she lost 2%, so instead of 100%, she's only got 98% of her original pay. Men earn 17% more than women. Women earn, so if men earn 17% more, so if I say this is a woman's value, 100% of it, then men would be 117 of that. So if a woman made $100, a man would make $117. So a woman earns what percent of what the man earns? So I would have to now reverse that and say 100 divided by 117, and it's 85% of what a man earns. It's just not subtract 17. You have to actually do the ratio. Jonathan's prize antique car was $115% of last year's value. The car was worth what percent less than its current value? So if it went from 100% to 115%, and we want to go backwards, we're going to have to make the denominator 115 and the numerator 100, kind of like the last problem. So it's going to be 100 divided by 115, and it's 86%. Oh, it's worth 86%, 86.9, 87%. So it lost 13% because it's now 87% instead of 100%. It lost 13. Going back, it was 13% less than its current value. Okay. This is kind of an estimation problem. 25.8 million pounds of beef consumed in the U.S. Each head of beef yields 650 pounds of each head, each cow, each steer produces 650 pounds of beef on average. So 800 million pounds of beef and then each head is 650 pounds, so we want the pounds to disappear. and we want to get the number of heads, number of different cows, that's counted in heads, and there's 650 pounds is one animal, and this was in per year, and now we have to get the years to be per hour. So there's 1 year, got to put it in the numerator so years cancel, is 365 days. And then we got to get hours, so a day is 24 hours. So we've got 258,000,000 divided by 650 divided by 365 divided by 24. 4.53 head per hour. Forbes listed Carlos Slim Helu family as the wealthiest in the world at $73 billion. If a stack of $10 bills is 1 millimeter thick, 10 $1 bills. So $10 is 1 millimeter. How high would a stack of 73 billion? So we got 73 billion $73 billion, and then we got to get the dollars to disappear. So that would be $10 is 1 millimeter, and then we got to get millimeters to kilometers, and so we got millimeters has to go, and there's 1,000 of those in a meter. And then we got to get the meters to go. 1 meter is 1,000 meters is 1 kilometer. So we would end up with dollars getting canceled, millimeters being canceled, and meters being canceled, and we'd get kilometers. So we have 73, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 10. 10 of them make a millimeter, divided by 1,000. That gives us how many meters, divided by 1,000. That gives us how many kilometers. 7,300 kilometers high. Higher than the highest mountain in the world by a lot. The highest mountain in the world is about 10 kilometers. All right, scientific digits. So the number of significant digits in scientific notation, they always give you the number, all the significant digits. So there's 3. The implied absolute error, so that's plus or minus the next place, which is going to be, and this is times 10 to the 5th, so that's going to be 0.005 times 10 to the 5th. So 5th would move the decimal 5 places, 1, 2, 3, 4, 5. So that's 500. And if you .005 is the next decimal place times 10 to the 5th, 500. So the absolute error is 500, and the implied percentage error is going to be 500 over 7.08 times 10 to the 5th times 100. So 500 times 100 is 50,000. Let's just make sure I do it right here. So 500 times 100 divided by 7, and let's get this answer. And then I got to divide it by 7.08, and I also have to divide it by 10 5 times, divided by 10 to the 5th. And I get this, which is divide by 10 5 times, so it's 0.00. What's on here? 500 times 100, 5,000. Oh, I didn't do divided by. That's what's wrong. The number didn't look right. 50000 divided by 7.08. Wasn't watching what I was doing. That's this number, and then I have to divide that by 10 to the 5th, and I get 0.0707% error. Pretty small error. Now, the reason I did divide by that, enter, and then divide by that, if you typed in the 50,000 or even just the 500 and tried to divide by this, divided by 7.08 times 10 to the 5th, you're going to get the wrong answer. Yeah, we got way bigger answer than this. And that's because it divides the 50,000 by this number and then multiplies the answer by this. And we're supposed to be dividing by that. To do this correctly, we would want to do parentheses around what we're dividing by. And if you don't put the parentheses, you're going to get a really wrong answer. Okay? You got 10 to the 10th times bigger than the right answer. Okay, how many significant digits here? Well, that 0 counts because it's past the decimal. So there's 4 significant digits. So the error is in the next place. So it's 0.005, 1 past the last significant digit, plus or minus that. And so our percentage error is 0.005 divided by the original number, 22.40 times 100, and we get 0.005 times 100. I better type it all in, 0.005 times 100 divided by 22.4, and I get 0.02% error. And the last one, 400, there's no decimal, so these are just placeholders, so there's only one significant digit, and so the error is plus or minus 50. the last significant digit is 4 in the hundreds, so it's half of the tens, half of 100, which is 50. So I got 50 divided by 400 times 100, and that turns out to be, I think, 12%, 12.5%. But I'll show you. 50 times 100 divided by 400, 12.5% error. Okay. Backside. Which number in the different parts of problem 6 is showing the most precision? Most precision is the one with the least percentage error. So that would be B. Smallest percentage . Which shows the least precision? And that would be C, because it's got the biggest percentage error. C. Okay. Simplify the following. Use the rules discussed in this chapter. So the area of a rectangle, show the correct number of significant digits. So there's 3 here and 4 here, and the rule of thumb is to use the number of significant digits that's in the least significant number. So there's only 3 in this, so we're going to do 3. So we're going to do the whole thing, 49.5 times 71.45. Nope, didn't put in the times. 49.5 times that. Enter, and I get 3536.775, but I got to round to 3 decimal places. So I would have to go, which is approximately 3540 meters squared. Here I have 5 significant digits and I have 4 here, so my answer's got to be 4. So I got to take 21.2 minus 5.3059. I get this, but I can only do 4 significant digits, so that's 1589 rounded there. That's 4 significant digits, yards. Find the minimum value of the rectangle width where the estimates for the length are this. So there's 3 significants there, 3 there, and the volume is length times width times height. So I'm going to be multiplying these. But if I'm looking for the minimum volume, I'm going to use the lowest possible number that would round to this. So that would be 20, be half of this unit less, so 29.25. Do minus the half in the next place, times the half in the next place would reduce this to 39.95. Next spot is hundredths, and I got to take 5 hundredths off of this. Next spot on this is hundredths, so I got to take 5 hundredths off of that. So that's going to be times 18.05. And so those implied errors are going to give us a value of 29.25 times 39.95 times 18.05 and 21,092.10188, but we can only do, there's 333. We do 3 significant digits, so I'd have to round this to 3, so it'd be 211 centimeters cubed. So we're doing 40,000 people, and 6,000 have the virus. So that means there's 34,000 that don't have the virus. And this is one where there's 2 different ones. So 4% of the time, the virus incorrectly diagnoses the virus is present when it doesn't. So a positive test when they don't have the virus is 4%. 4% of this. So 34,000 times 0.04. So that's 1360 goes here, and 34,000 minus 1360 is 32,640. So these are the false positives. And this is a true negative. Doesn't have it, and it true negative. Just to make a note. Then correctly predicts 97% of those that do have the virus. So there's 6,000 that have the virus times 97%, 0.97, 5,820, and that's a correctly predicts they have it. So test positive for the virus that have it, so that's 5,820. And so that leaves 180 that get a test negative but do have it, so that's a false negative. And this is a true positive. So I can add these and I can get 5,820 plus 1360, and that's 7,180. And if I add these, I get 3,2,640 plus 180, and I get 3,2,820. And so I completed the table. What's the chances of someone testing negative and having the virus? So they test negative. That's the denominator. So 3,2,820, and having the virus, and that's only 180, and we have to make it a percentage. So we get 1,8000 divided by 3,2,820, and we get 0.55%, less than 1% chance. Okay, so now we're supposed to figure out, I've got all these here, 22 of that, we have all these here. We're going to figure out the cure rates here. So 22 divided by 120 is 18.33%. 46 divided by 80 is 57.5%. 20 out of 120, that's 16%. So this is 17%, rounded better. 16.16 and 2/3%. 16.6%, 16.7%, something like that. And this one, 100 divided by 180 is 56%. So drug A does better for the men. It does better for the women. So drug A was better for men and better for women, had a higher percentage. Drug B, let's see. Now let's do overall percentages. So 22 plus 46 is 68. 68 divided by total number patients cured or tried is 200. So that's 34% overall. Overall, drug A is 34%. Drug B, 20 plus 100 is 120, divided by 120 plus 180 is 300. That's 40%. So overall, B has a better percentage. Okay.